You don't have to, it doesn't say reduces, it doesn't say simplify. It just says state the domain. That's all it says. Number 6, yeah. Page 469.
What section?
Section 6.1. Do you guys understand? There's still a question. Now, if you do the work, which you do not have to do, what happens?
Yeah,
Those cancel.
+2.
Those can only cancel if x is not 2. If x is 2, you got 0 over 0. What is 0 over 0? It ain't 1. And it ain't 0. It's weird ass shit is what it is. It's even worse than undefined. It's what's called indeterminate. It's terrible. So I know that it looks like these cancel. They cancel as long as this is understood. And really in mathematics, when I write this function down, I'm implying that x can't be 2. By writing it down, I'm saying x can't be 2. So everything I do after that is saying, oh, as long as x isn't what it's supposed to not be. Right? So x can't be 2. The minute x is not 2, I can do all this kind of weird stuff with it. It's fine. Because again, what do you get here when you plug a 2 in? 0 over 0. That's undefined at least. What do you get here if you plug a 2 in? 4. So it's not equal to each other then, is it? This doesn't equal this if x is equal to 2. I don't know if you quite get what I mean, but do not simplify before you find the domain. You find the domain first, because if anything cancels, you lost that piece of information. X can't be 2. I don't care what you do next. X cannot be 2 from right there. Cool.
Yeah.
So I know it looks like it cancels, but it can only cancel if x is not 2. You got to say that first before you can really do any work.
So number 9 is the same?
Same way. That whole little section, 6 through 16. 5 through 16, they just want the domain.
The same because...
Don't do any work.
No.
Just what makes the bottom 0.
Because minus.
Where are we at?
Number 9. The same page.
Just look at the bottom. What makes the bottom 0?
So
like on number 9, it says something over 3x minus 15.
Yes, minus.
3. Right? So you say to yourself, okay, the bottom
Yeah.
can't be 0. And then you solve and you eventually get to 5, right? So if you want to make a little inequation to work out, and see how I say it in English, the bottom. Okay, what is the bottom in this case? This can't be, does not equal 0. 0. Solve it, bam. You're going to figure out what x makes it 0, so I throw it out. It's a really good way to do domain questions. Say it in English, write it in Mathish, and then work it out.
If it is 0,
If x is 0, it's fine.
yeah.
So be careful, it isn't x equal to 0, it's just the bottom can't be 0. So whatever x is to make the bottom 0, like Kevin said, if you solve this thing, you get x cannot be 5. Because if x is 5, you get 15 minus 15 is 0.
0, yeah.
Okay. Alright, maybe one more question. Another, yeah.
5-8, number 30.
What, 5-8?
Yeah, number 30.
30. Oh, yeah.
So you want us to put all real numbers except 2, that's number 6.
Yeah, you can do that or this, either way. Okay. Now this is one, and to me the best way to look at this is somebody factored it too early. We have to undo their mess. Because you only factor it once you get the equation set to 0. So see, they factored the side, but they didn't suck this stuff over. So that's why you have to actually multiply this out. Undo what they did, suck this stuff over, and then refactor. So this is the worst problem, really. They've done extra work they shouldn't have done. You've got to undo that work first. That's right. I always say math needs musical intermission. So FOIL it out. On this side, you can do what? What's up? Is over there?
7R plus 7.
All right. And this side, you multiply it out. Plus 2R minus 3R is minus R. So you undo the little bit of work they did, whoever they are. That's one way to look at this problem. That's the way I like to look at this problem. Somebody did some work already, they factored it, you crazy fools, you gotta unfactor that damn thing out. Pull this stuff over and then factor it, because you're only supposed to factor it once you get it equal to 0, and they didn't do that. That's the worst problem, because you got like extra work to do. That's too bad. Right, so now you add the 7R, you subtract the 7, and I'll let you guys finish out, because now you just have to. And that's actually, why is this not bad? What's the first thing you always try when you're factoring? Greatest common factor. They each have a
3.
Yeah, so this is not, I don't have to do 3 times 9. I can take a 3 out.
Yes.
So it's not nearly as bad. I'm going to let you guys finish that up. So factor this, set each piece equal to 0, you're done.
Yeah, I messed that all up. I just took, I tried to do like take the negative 7R and I tried to make it positive and took it to the whole other side.
Oh, well that's basically, I mean that's basically what you do here, but you have to
I didn't
foil this out first.
See, I didn't foil either.
Oh, okay.
That's right.
See, I like to look at it like you got to foil this out so you can suck that stuff in.
Okay.
If you add it right now, there's nowhere for that 7R to go, because these are all contained. If you multiply it out, now the 7R can go with the R.
See, what I did, I kept the whole parentheses and brought it over. I just did it like all equals 0.
I got you. So you did this. Plus 7R minus 7 like that.
Yep. That's what
Now, of course, right here, you don't have a product here. You have something plus something minus something. So you can't set each factor equal to 0 because you don't have factors yet.
Alright.
You need this entire side to be multiplied. And right now there's pluses and minuses. So that's what tells you, oh crap, I got to multiply this back out so I can suck this stuff in and then refactor. I need it to be like this so I can set each piece equal to 0.
Alright. Okay.
Right here I don't have pieces. I got this and then this extra stuff here. Yeah. All right. So a little review of the last section we did, which was 6.4, I think. Real quick. Because then 6.6 comes right off of that. It's the same idea. How much should we do out of 6.6 now?
Number 30, which is page,
Oh, shoot. Oh, it's page 443. 5.8. Okay. It's like a preview, right? Yeah. All right, you guys help me out here. How do you do? Let's start off with something gross. Why not?
what section? 4,
Section 6.4. I'm going to try to show you guys a shortcut. Anytime I show you a shortcut, you obviously don't have to use it. You can always do it the long way, right? Which one of these is easier to factor?
The bottom problem.
Which one would you rather have as a problem on a test?
The 4.
This one, right?
Squares, yeah.
That's a little thank God problem, isn't it?
Yes.
So how's that guy factor?
2x minus 3. 2x.
Now, what do you think has got to be true about this guy related to what I just did? What do you think is going to happen? This guy is going to have
something similar to that.
one of these in it.
Yes.
And the other one's going to be what he's missing, right?
Right.
Or at least that's what I'm going to assume. It's not necessarily true, but I'm going to try it and see. Now, what do I mean by that? I mean, I think that this is going to have 2x and 3. I don't know if it's minus or plus yet.
Yeah.
But watch how that's freaking cool. Especially if it works. I mean, if it doesn't work, shit, I got to do this long-ass way, which is the 8 times 9, 72, blah, 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 right? You can always do that. You can still do it. But I desperately want to show you how these problems give you hints. If there's a 2x there, what's got to go there to make the 8x squared? And if there's a 3 there, what's got to go there to make the 9? Now you just think about where is the plus or minus, right? So aren't I not? Kind of a... Am I not going to get a 12x here?
Yes.
And a 6x here? How am I going to make negative 6x as long as the 12x is negative? So that's going to be minus to make it negative 12x.
Yeah.
This has got to be plus to make it positive 6x. Then don't I get the negative 6x in the middle? I already made the first and the last work. Are you guys with me? I made the first one and the last one work. Now I made the middle one work. So this is the freaking answer. It's got to be. If you don't get that, you can still do the whole negative 72. Factors that to make 6. That would be the 6 and the 12. Nifty. Break it up, do the grouping. You'll get here eventually, right? Anytime I show you a shortcut, you can still do it the old way. Nothing wrong with the old way at all. You probably need some practice with that anyway.
Can you explain that shortcut one more time?
Yeah. So I know, I'm really damn sure, and you should have seen this by now by a lot of these problems, that it's going to share. That's going to share something with this one. So in this case, it's nice because they both have a 2x and a 3. If there were two different things here, then I tried both, right? But here, 2x and 3. I'm going to assume that's part of the answer. What's got to go here to make 8x squared? 4x. What's got to go here to make 9? 3. And then I just figure out what's minus and what's plus to make the middle term work. If the middle term doesn't work at all, that means my shortcut's not going to work, and then I have to do it the long way. Oh well. Most of them are going to, the shortcut will work. If you don't understand the shortcut at all, let it go. Do it this way. You got to be able to do that anyway. So that's good practice. So now you can just attack this like normal. Who's missing what? What's he missing that he's got?
4x plus 3.
4x plus 3? Holy. All right, you're not a good option. Ooh. And what's he missing that he's got? 2x plus 3, yeah. Okay. Right? I really want to show you that the shortcut's not necessary. My idea is, listen, I got to factor everything so I see what everybody's got, so I see what the other guys are missing. Right? That's the idea.
Don't you put a 6x in the middle, or you don't?
So I would get a 6x in the middle, right? Negative 12 plus 6 is negative 6x.
Okay.
If I multiply back out, just kind of check. All right, let's see. What do I get here at the end here? I get, and remember this little thing you could do? Make this plus and negative so you don't forget that negative if you want to. Right, that minus in the middle is always tricky. So what do I get here? 16x plus 12 minus 12x minus 18 all over this here, right? Because now they both have the same denominator. And now it's cleanup time, right? Once you do this step, you give everybody what they're missing. You clean it up now. Put your like terms together.
Grouping.
Well, not grouping, just putting it together. 16x minus 12x is
Oh.
4x. 12 minus 18. And what's the last thing you got to check now? You're basically done with the problem. But it's sort of like getting this as an answer. What do you have to check now? Will it reduce? Right? And what can you take out of the top? 2. And then, of course, that'll cancel with that 2x minus 3, right?
Right. So it's going to be.
So the answer is 2 over 2x plus 3. 4x plus 3.
Yeah.
That is exciting. Maybe not exciting, but at least I want you to be able to do it.